So in this video today, we're going to go over the review for the Mach 2. So let's go ahead and jump in here. So our first one is simplify negative 18i to the 243. Okay, so first of all, let's just talk about what our powers of I are. So when we're talking about our powers of I, we got I to the 0 equals 1, I to the 1 equals I to the 2 or second degree equals negative 1, right? And then I to the third equals cents, right? This is 0.25 cents. This is 50 cents because this is our quarter method that we use here, and this is 0.75, right? So now what we're going to do is we're going to take this negative 18 I to the 243, take this 243 and we're going to divide it by 4 because there are 4 quarters in a dollar, right? So when we divide 243 by 4, we get 81.0. So we're only interested in those cents right there. So this is going to be negative 18 I to the 0, and I to the 0 is 1, right? So negative 18 times 1, which is negative 18. So that's our answer. Our next one, this time we're multiplying some i's. So what I'm going to do is I'm going to do what we did in our lesson the other day. So that's going to be 3, right? Plus 8 plus 5. Those are our powers, right? And then we've got our coefficients. So I'm going to do 2 times negative 7, right? So that's going to be negative 14. And then this is going to be 3 and 8 is 11 plus 5 is 16, right, y'all? So this one is going to be, again, so now we're going to do our 16 divided by 4 again. That's going to give us 4.0 again. So that's going to be negative 14 times I to the 0. So that's going to be negative 14 times 1. So that was our answer, negative 14, which was A. Number 3 says simplify negative 6 times the square root of negative 567. Okay, so on this one, excuse me, I'm going to do negative 6 here, and then I'm going to take the square root of negative 1, and then I know it's not divisible by 2, but it might be divisible by 3. So I'm going to take 567 and I'm going to divide it by 3. And when I do that, I get the square root of 189. And I just happen to know that the square root of 189 is 17. So you might not know that. So you might have to actually do this another way. But 17 squared is 189. So here again, this is negative 6 times I times 17 square root of 3. So we're going to do the negative 6 times the 17. That's going to be negative 102 I square root of 3. So that's our answer right there, y'all. All right, so number 4. Hopefully you remember with this, we're just going to multiply by the conjugate for both the numerator and the denominator. So we're going to take the conjugate of the denominator, which would be negative 4i, and we're going to divide both these, or multiply both these by negative 4i. So that's going to be negative 28i over negative 16i squared. Now remember, we replaced the I squared with what? Yes, a negative 1. So this is going to be negative 28i over positive 16, right? Now, does this have a GCF? Yes, it does. So both of these are divisible by 4, right, y'all? So that means it's going to be negative 7i over 4, or negative 7 fourths I, which is the way the answer would be written on this test, okay? So the next one, number 5. So what do you guys notice about number 5? Yep, me too. So I noticed that it's not in standard form. So I'm going to put it in standard form first, because that helps me remember that I need to multiply by the conjugate, which is always changing the sign of the imaginary part. So this is going to be negative 2i. Sorry, what am I doing? No, we're going to change. It's going to be 1 minus 3i over 1 minus 3i, right? So on the top, 1 times negative 2i is going to be negative 2i. And then negative 2i times negative 3i is going to be plus 6i squared. Then on the bottom, remember, we're going to actually square both these terms, right? So we're going to do a 1 squared plus a 3 squared. So this is going to be negative 2i plus 6 times a what? Change that I squared to a what, y'all? Yeah, negative 1. Okay? And then that's all going to be over 1 plus 9. So this is going to be, let's move this over here. I'm going to go ahead and switch this around to standard form. So this is going to be a negative 6, right, y'all? Minus 2i over 10. Are we done? Oh, no, because everything's divisible by what? You got it. a 2, right? So this answer is going to be x equals negative 3 minus I over 5. So if we were to write this in standard form, we would write it this way, y'all. Negative 3/5 minus 1 over 5I. Okay? So that's our answer right there. This was our answer over here. That's our answer right there. Okay? So now we're going to factor completely here. So my big question with this one is, does it have a GCF? So obviously it's divisible by 2, right? What else is it divisible by? 3. Well, y'all, again, look at your answer choices here. Do y'all notice that all of these have a GCF of 3? So we're going to go ahead and do that. So that gives me 4x squared plus 36. So do you notice that these two things are squares? Me too. So that means I'm going to take the square root of this one and the square root of this one. Now, what do I know right now? Yes, all of you should know that I can mark through this answer right here. Why? Yeah, because there's a plus sign, and which means there's got to be an I in the answer. Now, what else do you know? One of the answers has to have a plus and one has a minus, right? So we could also mark out this C right here, yes? So then we got 3, and what's the square root of 2 or 4x squared? That's 2x, right? And 2x. Remember, we're going to have plus and minus here, and then what's the square root of 36? 6, right? So we're going to put 6i here, and we're putting the I. Why, y'all? Because we have this plus sign right here, right? That plus sign is what tells us we got to have an I in our answer. So that means our answer is where? Yeah, it's D. Any questions about that one? Okay, so let's move on to number 7. This one says factor completely. So once again, I need you guys to hear me here. We always want to deal with our GCF first if we can, okay? So this one has a GCF when we're factoring. So that's going to give us 4x squared minus 25. What do we notice about both these terms? Yep, they're both perfect squares again, so our pattern is going to apply. So this is going to be 2x plus 5 and 2x minus 5. Right? All right. So that was our answer there. Okay, so now on this one, it says solve. Oh, so y'all, I'm looking for patterns here, right? Okay, so on this one, I'm going to, do you guys notice that there's no b? Me too. So that means I'm going to use square roots. So I'm going to go ahead and subtract that 112. So this is going to be 7x squared equals 112. Then I'm going to divide by 7. Okay, so when I do that, I got x squared equals 16. So I'm going to take the square root of both sides, right? So this is going to be x is equal to plus or minus 4. That one's done. All right, let's look at this next one. This one says solve. Okay, so again, do you notice that there's no b? So on both of these, there was no b here. So right, there's no b there, and there's no b here. So when we're going to use the square root to solve problems that do not have a b, okay? So here again, we're going to go x squared, and we're going to subtract that to 52, right? Okay, so now everybody listen right now. So because we're about to take square root of a negative number, what two answers can we eliminate right now? Yep, the ones that don't have an I. Y'all see that? So now I said this to my students. So 28 has a factor of 7, and obviously 7 is a factor of 28. So I'm going to divide that 252 by 7 first. So when I do that, I get x equals, and I'm going to do plus or minus, that's 36, y'all. So this is going to be the square root of negative 1 times the square root of 36 times the square root of 7. And again, that was just a good guess from me. Why? Because 28 has a factor of 7. Do y'all see that? Okay, so x is going to be equal to plus or minus here, 6i square root of 7. Okay? So that was the answer here. Okay? All right. Number 10 says simplify. So there's a couple ways we could do this. We could do this with a special pattern, or we could do it with box, okay? So I'm just going to do it with box just because I don't like making errors. So I'm going to do 5 and 7i with my box method here because, again, it ensures that I make no errors. So there's 25, that's 35i, and that's 35i, and this is 49i squared. So we get 25. Here are our like terms. Y'all see these like terms right here in our diagonal? So that's plus 70i. And then we've got 49i squared. What do we change the I squared to? Yes, a negative 1. So this is going to be 25 minus 49, right? Plus 70i. So our answer is going to be negative 24 plus 70i. Now, here's the thing with this problem. We could have definitely marked out C because we know that there's got to be an I in the answer somewhere, right? But then whoa, I don't know what that was, y'all. Crazy. It just went crazy. Okay, let's grab it and stick it back up there. I don't know what that was, y'all. So anyway, our answer is B, right, y'all? Right there, okay? So, all right, the next one's simplify. So all we're doing here is the distributive property, right? So we're going to multiply that times that and that times that. So we're doing 3i times 9 plus 3i times 6, negative 6i, sorry. Okay, so this is going to be 27i, and this is going to be plus, oh, wait, that's minus, right? Negative, yeah, a negative times positive is negative, so that's negative 18i squared. What do we change the I squared to, y'all? A negative 1. So this is going to be negative times a negative is positive, so I'm going to write it in standard form, so it's going to 18 plus 27i. That's our answer, y'all. Okay? All right, the next one says combine. So this time all we're doing is let me move that little pen out of there. We're going to combine like terms. So we're going to put our constants in one set of parentheses, and we're going to put our imaginary numbers in another. So we've got 15 minus 4, y'all see that? Plus our negative 11i minus a minus 7i. So what happens when we have two negatives next to each other, y'all? We add, right? We change what's behind. So 15 minus 4, that's 11. And then we've got negative 11i plus 7i, so that's going to be negative 4i, right? It is. So there's our answer. So number 13. Now, this one, we're actually going to multiply that 2i times the 8 minus 6i, and then we're going to combine it with the next term. So I'm going to do that first. So that's going to be 16i minus 12i squared. Now, what do y'all notice about that I squared? Yeah, we're going to go ahead and change that to a negative 1. And so I'm going to keep simplifying this. 16i plus 12, right? Now, we've got this term plus, let me put my plus there, y'all, because we're just going to combine it, right? Plus 12 minus 15i, okay? So now we're going to put like terms in sets of parentheses again. So I've got 12 plus 12, those are my constants, right? Plus 16i minus 15i. Everybody see that? So on this one, we got 24 plus I. That's our answer. Now, the next one says calculate the discriminant. So this is what I need to point out to y'all. When we're doing the quadratic formula, we get negative b plus or minus the square root of what? The b squared minus 4ac. That's our discriminant right there, y'all. All over 2a. Okay, so our discriminant is what's in red. So we're going to do the b squared minus 4ac to determine the discriminant. So notice again here, and this is in the equation ax squared plus bx plus c. Where there's our a, that's 5, right, y'all? Our b, right there, is negative 8, so that's b right there, okay? And then our c is the 6, okay? So we're going to do b squared, so that's negative 8 squared minus 4 times a, which is 5, and c, which is 6. So this is going to be 64 minus 20 times 6, that's minus 120. So that's going to be negative 56, isn't it, y'all? So what does that tell us about our solutions? Remember, the discriminant can tell us about our solutions. So this is negative, right, y'all? And because it's negative, it tells us we're going to have two imaginary solutions, right? What if it was positive? It would tell us that we have two real solutions. And what if it was 0? Yep, one real solution. Okay, so now, number 15. It says solve. Okay, so when we're solving, we're going to factor this thing. Now, we could use a variety of things. Actually, let's talk about this problem. Are there any factors? We're going to do a times c, that's negative 2, right? Are there any factors of negative 2 that add up to be negative 11? No. Okay, here's the other question. Is the a 1? Yes. Is the middle term even? No. So we're not going to use completing the square with this one either because the middle term is not even, okay? So what is our alternative? It is the quadratic formula, right? So we're going to find a, b, and c. We're going to do that first. We're going to find the discriminant first. So we're going to use this red over here to find our discriminant. So we're going to do negative 11 squared minus 4 times our a, which is 1, and our c, which is negative 2, okay? So this is 121 minus, no, it's plus, right? Because negative 4 times negative 2 is positive, so that's plus 8. So this is going to be 129. So that is a positive number. So that means we're going to have what kind of solutions? Yes, 2 real solutions, y'all. So here again is our formula, negative b, so we're going to go minus a minus 11 plus or minus the square root of 129 over 2 times a. So it's 2 times 1. So our final solution is x is equal to 11 plus or minus the square root of 129 over 2. And yes, we have 2 solutions because we have a plus or minus in this answer. Do y'all see that? Okay, so here again, that was our answer there, and this is our answer here. So now we're on number 16. This one says solve. And by the way, if you can see all the answers, y'all, look like the quadratic formula, then you should probably use the quadratic formula, okay? So the first thing I'm going to do is move that 5a to the other side of the equal sign. So we got negative 8a squared minus 5a, nope, plus 5a, right? Because we're going to move it to the other side. Minus 3 equals 0, okay? So here again, this is our a, this is our b, this is our c. So again, I'm going to use the discriminant. So we're going to do b squared, 5 squared, minus 4 times a times our c. So this is 25, and we got negative times a negative, that's positive, that's negative 32, times a negative 3, that's going to be a minus, right, y'all? So this one is 25 minus 96, right? So that's going to equal negative 71. So pause right here. So we know that our answer is going to have what in it? I. Well, that did not help us eliminate anything this time, did it? That's okay. We're going to proceed, okay? So now we're going to put this in the formula, negative b. So we've got negative 5 plus or minus the square root of negative 71 over 2 times a, which is 2 times negative 8. Okay, pause right here now. So we got a negative 5. So do y'all notice that? We can cancel out a and c, right? Because neither one of those have a negative 5. And what else do you notice? 71. Do y'all notice 71? Okay, so I do too. So let's go ahead and finish this because I'm pretty sure that that's our answer, b up there, okay? So we got x equals negative 5 plus or minus, this is the square root of negative 1 times the square root of 71 over negative 16, right? So x is equal to, and that negative over negative makes it positive, plus or minus, oh, wait a minute. We're in trouble, aren't we? Notice. We marked out those negatives. Y'all see that? But when with this canceled out, why? Because we had 2 negatives over each other. So this is going to be I square root of 71 over 16. Okay, so pause. So which of these answers that are left are the correct answer, y'all? Because this time when we marked them out, that we shouldn't have done that, should we have? Okay, and this is why. Because this one, actually, the answer is A. Y'all see it? And the answer A is A again because we had a negative over a negative, and it makes the whole thing a positive, okay? So watch out for that when you guys are doing your work. Double check, okay? So on this 17, it says factor completely. So we're going to multiply A times C because it says factor. I don't have a GCF. So that's going to give me negative 12, right? So we're going to actually look for the factors of negative 12 that add up to be negative 4. So I'm going to rewrite this down here as x squared minus 4x minus 12. And then we're going to look for the factors of negative 12 that add up to be negative 4. Isn't that going to be negative 6 plus 2? So we got x here and x here. So that's minus 6, and plus 2. Now, we're going to take that bottoms up method, right? So notice we still got that 3 there. So we're going to divide this by 3, and we're going to divide this by 3. Now, if it can go into that constant, then what do? We reduce it, right? So this is going to be x minus what? 2. And if we can't divide that constant by the 3, then we do up and we bring it up. So this is going to be 3x plus 2. Okay, so it's going to be x minus 2 and 3x plus 2. So where's that answer? Yeah, I think it's A, y'all. It is. Okay. So then this next one says factor completely again. So remember, our first step is always what? A GCF. So we're going to do that first. So that's going to give us 2x squared plus 7x minus 4, right? So the first one and the last one don't have the GCF of 2. Do y'all notice that? So I can mark through those. Then I just need to factor this thing, okay? So once again, we're going to multiply A times C. That's going to give us negative 8. And we're looking for the factors of negative 8 that equal 7, right? So isn't that going to be 8 minus 1? So we're going to put in our parentheses again, our x and our x. And plus 8 and minus 1. We're going to divide again by our leading coefficient right here, y'all, 2. So this is going to be divided by 2, and this is going to be divided by 2. So this one's going to be x plus 4, right? And then we're going to do bottoms up here. So this is going to be 2x minus 1. And remember, we had that 2 out front, so we have to bring it down, okay? So 2x minus 1 and x plus 4. I think that's it right there, right, y'all? Okay. So number 19. This one says solve. So we're looking for the factors again. So I'm looking for the factors of 77 that add up to be negative 18. And this seems to be the kind of problem y'all are having a lot of problems with. So look, the only factors I know of 77 are 1 and 77 and 7 and 11. So if I do 7 and 11 here, y'all, what do both of them have to be to add up to be the negative 18? They have to be negative, don't they? So this is going to be x minus 7 and x minus 11. Now, when it says solve right here, that means we're going to set both our factors equal to 0. So this is going to be x equals 7 and x equals 11, right? That's our answer. The next one also says solve. So once again, I'm always looking for a GCF, y'all. Does number 20 have a GCF? Indeed. So we're going to factor that out first because it's going to make our problem easier, okay? So this is going to be minus 3x minus 10, right? Equals 0. So now we're going to factor this. What are the factors of, again, negative 10 that add up to be, let's actually make some space here. So we're looking for the factors, y'all, of negative 10 that add up to be negative 3. Isn't that going to be minus 5 and plus 2? So in our set of parentheses, again, we've got x minus 5 and x plus 2. We had this factor out here, 5, but remember, that's always going to go away because we are going to divide by it. So it's actually just going to go away. So then we're going to set our x minus 5 equal to 0. So that's x equals 5, right? Always the opposite. And x plus 2 equals 0. So this is going to be x equals negative 2. This one says use the polynomials that represent f of x and g of x to answer questions 21 and 22. So g of x, we're going to do g of x minus f of x. So we're going to do 4x minus 5 minus, and I'm going to go ahead and put this in, well, actually, yeah, standard form. So I'm going to do negative 8x to the third plus 3x plus 2. And what are we going to do to all the signs in that second set of parentheses if we're subtracting everything, y'all? Yeah, we're going to change this to a plus. We're going to change this one to a minus. We're going to change this one to a minus. Then we can just add them, right? So now we're just looking for like terms, okay? So we don't have another 8x to the third or x to the third. So we got 8x to the third. But notice here we do have an x to the first. So we're doing a 4x minus 3x. So that's just going to be plus x, right? And then we also have two constants. We have a negative 5 and a negative 2. So that's going to be minus 7. Okay, So that's x to the third plus x minus 7. Now, number 22, we're actually multiplying these, okay? So we're going to multiply f of x. So again, I'm going to write it in standard form. So I'm going to do negative 8x to the third, and I'm going to do 3x, and then I'm going to do 2. Now, the reason I do this when I'm doing the box method, which is what I'm about to do, is because when I write it in standard form, then in my diagonals, I'm going to get my like terms, okay? So let's go ahead and do this with the box. So 4x times negative 8, 4x times negative 8x to the third is going to be negative 32x to the fourth, right? Then 3x times 4x is 12x squared. Then 2 times 4x is 8x. Then we got negative 5 times negative 8. That's going to be 40x to the third, right? 3x times negative 5 is negative 15x. And then we got negative 5 times 2, which is negative 10. Okay, so if we have any like terms, they're going to be in our diagonals, right? So notice this time we don't have like terms here and here, do we? So I'm always going to double check that just to make sure I didn't make an error, and I did not. But we do have some like terms right here and here. Do y'all see this? Here and here, we do have some like terms. Okay, so our answer is going to be negative 32 x to the fourth, and then plus 40 x to the third plus 12 x squared. Then we got negative 15 and positive 8, so that's going to be minus 7x minus 10. So I'm going to double check with my paper to make sure I got the right answer, and I did. So that was the answer to that one, okay? Then we got 23. It says use the rectangle to answer questions 23 and 24. It says calculate the perimeter of the rectangle. Now there's a couple ways we could do this. Obviously, a rectangle, opposite sides are congruent, right, y'all? So this side over here is going to be 3x squared minus 4. And this over here is going to be 7x plus 2, right? So can't we just add all of those together? We could. Or we could know that perimeter is equal to 2 times the length plus 2 times the width when we have a rectangle, right? So you can do it whichever way you want. What I'm going to do for this part is I'm just going to look for my like terms. So these are like terms, right, y'all? So isn't that going to be 6x squared, right? And then I've got some other like terms over here, 7x and a 7x. So that's going to be plus 14x, yes? And then I've got my constants. Y'all see the constants here? So I've got a negative 4 and a negative 4. That's negative 8 plus 2, which would be, and 2. So that's negative 8 plus 4. So that would be minus 4, wouldn't it? So, did I do that right, y'all? Let me pause. So now, hopefully you guys remember that area is length times width, okay? So on this one, area equals length times width. So all we have to do now is multiply these together, right? So I'm going to do 3x squared up here and minus 4. And I'm going to use my box method, 7x and 2, okay? So that's going to give me 21x to the third minus 28x. And then we got 6x squared and minus 8. Now, do you notice this time we don't have any like terms? Y'all notice that? Now, the reason for that is because we didn't have the same degree polynomials, okay? And when we don't multiply the same degree polynomials, we're not guaranteed that we're going to have like terms in our diagonal, okay? So this is going to be 21x to the third plus 6x squared minus 28x minus 8. Okay? All right, so we got one more problem to go. This one says simplify. So this time we're just multiplying, okay? So you could just use the distributive property order first, because then when I get done, it's going to already be in descending order, okay? So negative 7x to the fourth minus 2x squared plus 3x plus 5. So again, we're using the distributive property here, right? So we're going to multiply that times that. That's going to give us negative 28x to the seventh, right? Then we're going to multiply this times that. So that's going to be negative 8x to the fifth. Then we're going to go back to red again, or yeah, we're going to go to green again. Now let's go to black. There we go. So this to that. So that's going to be what? Plus 12x to the 4th. And yeah, now we'll go back to green. So then we're going back to this, right? So it's going to be plus 20x to the 3rd. So negative 27x to the 7th, negative 8x to the 5th, plus 12x to the 4th, plus 20x to the 3rd.